Okay, so first one, factorize. That means put it back into double brackets, and in this case it's quite easy because there's no coefficient in front of x squared. So you're just looking for a pair of numbers that times is to make minus 14, and they add to make minus 5. Okay, can anyone think the pair of numbers that do that? 7 and minus 2? Sure? Minus 7 positive 2, because minus 7 times 2 is minus 14, minus 7 add 2 is minus 5, so that's just x's that go at the front. Okay? You could get asked to solve that as an equation, put equal to 0 if that's what they'd ask you to do, and it would have always been the opposite to what's here, so x would have been 7 and x would have been minus 2 if that's the case. All good? This one here, there's a couple of different ways to do it. My class, do we get the denominators the same? Yeah, let's do that way then. Okay. Okay, thank you. So, let's get the denominators the same. Does 2 go into 3? No. Times them together, 6. They obviously both go into that. So what do I do to 3 to make it 6? Times it by 2, so I get 2x plus 2 on top over 6 plus, and then 3x minus 2 over 6 is equal to 3.
Would it be 3 then bracket 2 and then bracket 3?
Ah, no, yes, I believe so. Yeah, because I don't particularly like doing it the way that you like to do it. I think at the moment, yeah, I think you're right, Luke. Yeah, what I tend to do is I tend to pick out what we call the highest common factor of it, and I times every single bit by the same number. But if we've times that by 2, and we times both bits by 2, and that bit by 3, then we have to times both of these bits, don't we, by the same? Okay, well done. Yeah. Can I show you the way I prefer to teach it? So what I don't want to do, I don't want to confuse anyone at this close to your exam. So if you're happy with that and you know what you're doing, just go to one side and just try and complete it your way. But I'll show you the way that I do it. So I always pick out what is called the highest common factor, which is basically what we just did. We just said 3 times 2 is 6. And then what I do is I just times every single bit of the original by 6. So the original thing then is just going to be x plus 2 over 3. And this is going to be a plus, and then x minus 2 over 2. And then this is going to be just a 3. Okay, all good so far? So then what I do is I cancel out any denominators, which the whole point of times by the highest common factor gets rid of those. So how many times does 3 go into 6? Twice. How many times does 2 go into 6? 3 times. And there's nothing to cancel off over this side, but can you see we've got exactly the same line as above then? Because 2 times 3 is 6. It's the same idea, so well done to Luke who spotted that. Okay? So either way now is exactly the same. It's whichever way works for you. Don't change your method that you can do this close to the exam.
So, as a general thing, if the number on the right, you have to times by both.
Both, yeah. Whatever you do to one side, you must do to the other side.
Why wouldn't you put it over 6 as well?
What, this one here?
Yeah.
Because it wasn't over anything originally. I'll tell you what we could have done. If we put this over 6, that's a good point, Maddie, it would have had to have been that we'd times the top by 6, so it would have been 18 over 6. And then 6 times 3 is 18, isn't it? So it would have worked out. And then you could have cancelled the denominators. That's a good point.
Can you move it down? Sorry.
Oh, sorry, I didn't show that. Yeah, did you see that?
Yeah, I can see.
Yeah? I'll go and solve it from my one, okay? Laura Jane? Fine. Yeah. Oh, can I 3, 2, and 1? Can I just show yours? Make sure we're being courteous, please. Make sure we're being quiet when I've asked. Thank you. Laura Jane's done it so that she got them as 2 separate denominators, left it as, and then put it all over one denominator there, and brought it round to times the 6 by there. There's loads of different ways to do this. It's whatever you're comfortable with, okay? Stick with your method that you know that works. And if you haven't got one, then go and ask me and I'll go through it with you, okay? So from there, for me, I would have expanded that out and got 2x plus 4. What you have to be careful with is if you ever get a minus here. So if that's minus, just have your wits about you because that'll change both the signs in here. Okay? So then I'm going to get plus 3x minus 6 and have that equal to 18. That's going to give me 5x from the 2x add the 3x. Plus 4 minus 6 is minus 2. That equals 18. So 5x equals 20, so x equals 4. And there's a very, very simple way to check if you're right. Chuck in 4 into the original thing. So I would have had 4 plus 2, which is 6. 6 divided by 3 is 2. Just write that above, plus. And then 4, take away 2, is 2. 2 divided by 2 is 1.
3.
2 plus 1 is 3. Yeah, that's right, isn't it? So I know I'm right. I can leave the exam knowing I've got those 4 marks.
Sorry, I missed that. Why do you need another 6?
Which ones? For my ones. So the way that I cancel mine was I picked out the highest common factor and I times every single step by 6. And it's fine, you can do that. As long as you do everything to one side, you do it to the other, it's not a problem. And then I said, right, how many times does 3 go into 6? Twice. How many times does 2 go into 6? 3 times. Okay? The one thing I say, Callum, is that if you're unsure, use your way that you're happy with, okay? I quite liked your way in hindsight. It's good. Okay, guys, thank you. Still waiting. Thank you. Okay, and so expand and simplify. So we have 2x times them by the 4x. Careful with this, it's 8x squared. People forget the squared most commonly there, but some people forget the 8 as well. 2x times by minus 3y would be minus 6xy. And then plus 5y times 4x would be plus 20 what?
XY.
Not yx? xy? Excellent answer. It doesn't make any difference. Okay? The timesing, when you do like 3 times 2 times 4 is 24, and then if you rearrange them in any order, it's always equal to 24. It doesn't matter when you're timesing. Always try and get them into alphabetical order, and then if they have x and y, then you can cancel those bits down. Plus 5y times minus 3 is minus 15y squared. And from there, there's only one thing I can cancel down. There's no other x squared, so that 8x squared has to remain the same. There's no other y squared, so that 15y squared. Go on, Maddie.
14xy.
What sort of 14?
Positive.
Excellent. Well done. Okay, that's a nice 3 marks. There's not a lot of work there.
So I'm liking this paper.
It's not bad, is it?
Oh, yeah.
Yeah, is it? 3 marks. Make B the subject of the formula. Problem.
Oh, I hate this.
B is on both sides. Get B onto one side, then factorize. Very good. Okay. So it doesn't actually matter which side you get them on, but it seems a bit silly to get BC coming over and getting nothing left on that side. So I'm going to take BD over. So you get BC minus BD equals E. Then, because B is in both bits, I take it out as a factor and get C minus D is equal to E. And then finally, I'm going to get B is equal to, and then because that's timesing, I take over, it divides. Do I still need the bottom bit in a bracket? No. If you want to put it in though, it's not wrong. It's whatever you're comfortable with, okay? It's nice 6 marks.
It's not 6.
Yeah, the 3 and 3, sorry. Yeah. Not quite, sorry. You're quite good, Ken, and you've been up a couple of times.
Oh yeah, she's not sorry.
Okay then, thank you. So we're told that each time that he fires an arrow at the target, the probability that he hits the centre is 0.3. So that means, when I'm starting to fill in my branches here, I can fill in 3 of them straight away, 0.3, 0.3 and 0.3. Okay, basically these branches have to add up to 1, so 3 add what makes 10, so 0.7. And then that means all those must be 0.7. Okay, so easy 2 marks there, really, really easy 2 marks. Second bit trickier, it says calculate the probability that George only hits the centre once. There's 2 ways to do this, method 1 and method 2. Method 1 is probably the most sort of like obvious way, but there's a quicker way, so I'll show you both. So he hits the centre, so there you go. That works, doesn't it? He hits the centre at least once there. Here, he's definitely hit the centre once, yeah. So even though he didn't hit it the second time, he hits it at least once.
Only.
Ah, well done. Then there's not 2 methods at all, I lied. There's only 1. So that's no good, is it? The top one, because he hits it twice. This one here,
Yeah.
this one here, Find these two probabilities, add them together. So 0.3 times 0.7. Good. Common wrong answer I see there from like loads and loads and loads of different people. Like 2.1 they say. Why can't it be 2.1? Because it would be foolish. Well done. Any idea why it can't be 2.1? There is a specific. All probabilities add up to 1. There's no way it can go above 1, is there? And then this one here was 0.7 times 0.3, which is 0.21 again. So my chances were 0.21 add 0.21, which is 0.42. For 3 marks, that is very, very generous. I was a little bit guilty at looking at the marks then and assuming it was what I was saying because I didn't really read the question. Read the question, first and foremost. If it did say at least once, then this one here would have also been included if it did say at least once, and then I would have had to add on 0.3 times 0.3. 0.42? All good? Quicker. Very good. Grand's good at doing that, isn't he? Grand's quite good at doing that.
No, I thought it was like that.
Okay then. Thank you. So x squared, as the girl said, is the happy face. Okay, so that's what x squared looks like, minus x squared. Unhappy face. I'm going to skip 1 over x at the moment. X cubed is steeper than x squared. Obviously it's rising quicker, but when you have a negative, it comes into the negative, so it does that. Okay? They call this point here special, it's got a special name, it's called a point of inflection, but I can't see that coming up at GCSE. If you had x to the power of 4, what would that look like?
Like that being steeper.
X and like the first one, but steeper because all the negative values go back to being positive. Because you times the negative by a negative, it's positive. Times by a negative again, it goes negative like we just saw. But times by a negative again, it goes back to being positive. So for odd powers, you're always going to get this sort of shape. And then for even powers, you're always going to get just positives.
So if it was x to the 5,
It would be like this, but steeper.
steeper, closer.
So it would be, closer to the y-axis. Okay, x to 7, steeper again. Jess?
That was y equals minus x cubed. Would it be the other way?
It'd be the flip around. Very good question. Well done, Matt. It has come up a couple of times. 1 over x. Can I explain this one? Okay, so if you put into a calculator, which obviously I know this is a non-calculator paper, if you put into a calculator 1 divided by 0, it will say math error. You can't physically divide by 0. If I have £1, if I say divided by nothing, well, it exists, it doesn't work, okay? So if I start thinking of some points here, if I think of it being 1 and 2 and so on, then 1 divided by 1 would just be 1, wouldn't it? Okay? 1 divided by 2 would be a half, so it would be there. As I just divide that by like bigger and bigger numbers, it's just going to get smaller and smaller and smaller. But if I have like £1, I still share it between like 100 people, it's still going to get something, just very, very small amount. Okay? Now what happens here? What happens when I divide by a half? How many halves fit into it? It gets bigger. So what happens is it goes through 2. So what happens is this starts to shoot up like that, but it will never quite hit. Very good. It's called an asymptote. It will never actually hit the y or the x-axis, and then what happens in the negative side is exactly the same, but the other way around. So it's going to look like that. So it's 2 disjointed graphs. Okay. I probably do, yeah. I would have thought so. Remember, I've got the certains up now, haven't I, Maddie? Certs went up, didn't it? Okay, remind me on Ed Road, because I knew you had that one. question. I've never seen that at GCSE. I'd be thinking about that one as well. I think my idea would be that it'd just be steeper, and that would have to be in the positives because then negatives wouldn't count, would they? But I can't see that. Okay, good question. I think they'd both be in the positive, so that you can have a negative card. Good question, really good question. Okay then, 5, 4, 3, 2, 1. Thank you. Okay then, thank you. Thank you. Okay, B is the one where you're most likely to make your mistake. Even though 13 is definitely harder, A is probably not that bad, but B is where people will lose marks here, okay? So, first one, can you spot a number that's in both? Yeah, 5. Can you spot a letter? X. Bring it out. 5x times what makes 5x squared? And then minus 2, very good. Okay, so those 2 marks are fine. This one here is where people, honestly, they make massive mistakes. What's the letter that's in both? X. So we pull x out. Is there a number? No. So that's going to be x minus 6 equals 0. Okay? Now that's telling me a number times by another number, they multiply to be 0. So one of those numbers must be 0 for that to happen. If it's like 1 times the 6th, that'll just go to 1. Okay? So either x equals 0, either this thing outside, this equals 0, or this x minus 6 equals 0. Okay? Now that one's already solved, isn't it? We're saying 0 there, done. So I've got to take the minus 6 over and it becomes positive 6. So there are your 2 answers. So if I went and chucked either of those into that, it should be equal to 0. So x, if that's 0, 0 squared, take away 6 times 0, is 0, isn't it? So that's fine. And then x squared, so 6 squared is 36, take away 6 times 6, 36, comes to being 0 again, okay? But that's the one that people miss. They miss the x equals 0. I've seen some weird answers to that in the time by very, very clever people. And that is easier than that, and they don't think it is. It is, okay? It definitely is. It's a very, very repetitive idea. I would have thought you're pretty good at that.
Yeah.
Do you have a head start? Yeah, okay, I'll give you like a minute's head start and then I'll start writing a solution. I'm going to get the x's the same because they're ever so slightly smaller. Doesn't matter which ones.
Yeah. Yeah, but actually, I think that's why you put it wrong. You do what? 3 times 4 is 12. 23 times 4. Yeah, because you entered it. Yeah, that's mine. What? 36 minus 6. That's 3 times 3. Oh, no.
Minus 33 divided by 11. Minus 3. Yeah? It's a line graph plotted at the midpoint. So thank you for that lovely singing at the back. It's very kind. Just so we're crystal clear, that was a very sarcastic response from me, okay? Okay, just to point out something quickly in my solution. Thank you. Bit of quiet, please. Thank you. Something with my solution, the way I've got these, I've got 20y and 9y. Obviously the x is going to cancel. It's the y I don't want to be negative. So I'm going to do 3, take away 4. But that's going to give me 11y is equal to minus 33. It's fine if the other thing's negative. It's just if that y is negative, people make mistakes. Okay, you see the minus 11 going across. People change to a plus 11 because it's gone across and divide. It's the times that's important there that's when it's going across, okay? So y equals minus 33 divided by 11, ignore the minus sign. 33 divided by 11 is 3, then minus divided by positive is a minus. So y is equal to minus 3. Now I know that. Sub y equals minus 3 in, I'll probably do 1. So 3x plus 5 lots of minus 3 is equal to 9. So 3x minus 15 equals 9. 3x equals 24. X equals 8. So well done at the back, over got that. Very good. How can I be certain? Sub it into the second one. So 4 times 8 is 32. And then 3 times minus 3 is minus 9. 32 minus 9 is 23. Definitely getting the marks there. Nice easy 4 marks. Okay, this question here can look absolutely identical, but they might change literally one word from being a frequency polygon to being a frequency diagram. You've got to know the difference between the two. Polygon means line graph. It's going to look like a shape, except you don't actually join it up at the very, very end points, and you'll see what I mean in a second. The second bit that is absolutely crucial is that it's plotted at the midpoints. If you miss that, then you won't get the marks. Okay? So, line graph. So what you could do up here, if you wanted, is actually split that into being MP for midpoints, so 1, 2, 5, 1, 3, 5, and so on. Okay? And then you actually just go and plot it at those points. So 1, 2, 5, and then 2. So just go roughly around there. And then 8.
Do you mind just moving it up a little bit?
Oh, yeah. All good?
Sorry, so I just went to the
No,
bottom.
no, it's alright. It's fine.
Yeah, thank you.
And then we've got 1, 4, 5, and 13. Okay, you've got to be careful with the 13. So the scale there is 12 to 16, so halfway would be 14, and then halfway of that would be 13. So it's actually like floating in a square. Not a very nice graph here. It's like the one you had in your mock. Graph paper's rubbish, isn't it? 1, 5, 5, 22. There, I think. And then it's hard, isn't it? In your actual WJC exam, it will definitely be really nice graph paper. It will definitely be really. It's just a photocopy.
Just squeeze so small.
Oh, no, it helps it easier to find.
Oh, I can't do that.
Okay, now in terms of a polygon, make sure you listen to this bit, please. In terms of a polygon, obviously what I would do is then go and join this up. Now don't really do this, I'm going to rub it out in a second. And then I've got a polygon, haven't I? I've got a sided shape, a many-sided shape. You just don't join up the last 2 bits. Okay? So that's how I remember what a polygon is and what a diagram is. A diagram is just a glorified bar chart. Can I show you that, please? Can you bring it up? Yeah, you bring it up, It's good to talk about. Now what Luke has done here is he's put in a group frequency diagram as well. Now I've done a little bit of marking, and the last time I did marking it said if they put down both, give 0, you cannot choose for them. Okay? Well, it's interesting to talk about, isn't it? That's why I asked you to bring it up, okay? Because how often do you get told that? It doesn't really come up in lessons unless you taught it, and you got taught this before. I've not gone over this with you, so I'm really pleased that you've done it. Okay, so last time I marked these sort of questions, it said, do not accept if both graphs are on there, you can't choose for them. There was a time when they were giving it, and we were saying, look, just do both, and that way you can't go wrong, can you?
So why wouldn't you attach the first point to 0?
Attach the first point to 0, so you just wouldn't. You're just saying that, like, you're basically just trying to show how the data is being represented, so that doesn't go back on itself, does it? It's not like the next height would be like going back to its original.
No, wait, no, that doesn't. No, wait, no.
Okay then. Nice and quiet, please. This one's hard. I'm looking at this. I'm not thinking, oh, I obviously know the answer here. Okay, nice and quiet for this one, please. So Gareth was asked to use the following clues to find the equation of the mystery line. It's parallel to the one shown in the diagram. Okay, so what's that telling us about gradients? Is that ringing any bells? Excellent. Parallel lines have the same gradient. Okay, so I can go and work out the gradient of that line. It's not too hard to do that. And it says the mystery straight line passes through the coordinates 0, 5. Okay, so basically we want to be getting something in the form y equals mx plus c, where m is the gradient and c is the y-intercept. Good. I actually know what c is already. Does anyone else know?
Yeah.
5, because goes to 5. Tells us that. Okay. If they could have given us a nastier answer. They could have said it's like 1, 5, and then like you would have had to try and work out using the gradient where it would have gone through. So from here, to work out the gradient, you need to know a formula. Any ideas? Rise over run? Rise over step?
What's this?
Let's just put both and then there's no arguments. Okay? I actually remember it as dy by dx, which is difference in y's divided by the difference in x's. And if you're going on to A level, you see that notation all the time. Okay? It doesn't matter. It's just different things. I'm putting it there for myself more than anything else. Okay? Not to teach you another one, just so I can work it out myself. The best way to do it is to draw a triangle. And when you draw your triangle, pick nice points. If you don't pick nice points, then it's going to be really, really hard. I'm definitely going to pick that point because it goes through 2 and 0. And I'm going to pick this one here, I think, because coordinates at that point, 1 and 4. And this one here, 2 and 0. Okay. The other thing, what sort of gradient is that? Is that positive or negative? It's negative. I can already identify that it's negative, can't I? Okay. So I basically just want to draw a triangle there, work out its rise, divide that by its step or its run. So it's risen from 0 to 4, hasn't it? So it's gone up 4. Happy days? And then it's just gone across just 1. So its gradient is equal to 4 over 1, which is 4. But what sort of gradient did I just say it was? Minus. So it must be a minus. And you can do that just from looking at the sort of just looking at it. Yeah? All good? So what is the equation of the mystery line? Y equals minus 4x plus 5. Thank you, Sarah. All good?
You got with it, please.
Yeah, sure.
That's just you go straight.
No. Well, you just draw it. You go through minus 5, you keep your ruler parallel to that. And I just make sure it went through 5. So it looked like that. Okay, I'll just draw the line then. Good question. Those 3 marks there are damn sight harder than some of the stuff we've done in the A-star stuff for me. I didn't think that was as easy as some of the stuff we've done already. It's really, isn't it? I've noticed that. Number 8's hard. I'll tell you why number 8's hard. It's hard because it's time consuming. You've got to read everything carefully. The maths isn't actually that bad.
This is 7.
Some of these will be easy, some of them will be hard.
This is 8 and...
Careful with A part 2, those of you in my class, because it looks like it's set numbers, but it's sneaky.
It's minus 1, isn't it? Oh no, 0
Because it goes up by 5 minus 2. Well,
Jess, can you say again? That's perfect. I was just about to make that point.
Well, it's kind of like constant.
Good. If it's constant, it's the second difference has to be thinking. But if it's constant in the first one, which it is, then it's plus 8 or just 8n or plus 8n. Okay. Come and work out the number in front of the first term here. What would this number be?
5 minus 8.
5 minus 8, which is very good. So my answer is 8n minus 3. This one's not as easy as it looks. I'm here scratching my head a little bit. I'll need to do a bit of writing out for this. I know it's n squared. I can tell you that because they're the square numbers, aren't they? Bit I don't like about it.
Starts at 0.
It starts at 0. I don't like that at all. Because they're already the square numbers. If it was just that, it'd be easy. It'd just be n squared. But I'm thinking, is it going to be n squared that you then take away n squared, and then obviously n squared take away n squared would cancel out.
0 squared is 0. So it's fine.
Yeah, but you always start the first term is 1. Good point, though. So what you do is you look at the difference between them, which is 1, 3, 5, 7, and 9. So then you go and look at the second difference, which is 2, and if, as Jess, as you said, if that's constant, that is when you get an n squared. Not that it's 2, that's just a coincidence in this case. Okay? Now whatever that coefficient there, that 2, if you halve that, 2 divided by 2 is 1, that's the coefficient. This was pointing us right in 1 n squared, it's the same thing. Okay? So above this, I'm going to write out what n squared is. So n squared is literally the same numbers, but they start on 1, don't they? 1, 4, 9, 16, 25 and 36. And this is what I don't like about this one. You take away 1, take away 3, take away 5, take away 7. But the problem is usually it just works out that it's like take away 2 every single time. Now the fact that we've got -1, then -3, then -5, then -7, that's got another n squared sequence in there because they've got a constant difference. So that is a difference of 2, then a difference of 2, then a difference of 2, or a difference of -2, isn't it, every time?
Yeah.
Now the fact that that's constant again tells me that I'm taking away n squared, but then I'd halve whatever that thing is there, which is half of -2 is -1, so -1 n squared. But then the issue that I'm having here is that n squared take away n squared is 0. I need to double check that one, it's confused me. Okay, we'll come back to that one at some point today. I'll double check with.
Yeah, when they do -2, you should find the 2 before that.
Maybe only half.
Do you reckon? Yeah, what, just -2n? Do you think I'm overcomplicated? Oh, yeah, it's going down in 2s, isn't it? Right, well done, well done. You solved it. Right, I was overcomplicating it. So from here, sorry, can I jump in? This is just, it wasn't the second difference at all. The difference between those was just -2. So it's very similar to this one here being +8. Because it was going up in 8s, we said it was 8n. These are just going down in 2, so it's -2n. What would be the number in front of -1 here? Not -1?
-2.
If that's going down in -2s here, what's it going up in coming the other way? Plus in 2. So what's -1 plus 2? Plus 1. So it's going to be -2n plus 1.
What?
Do you want me to try and re-explain that? Because I confused myself. Okay?
That's just a bit 10 round.
That's a horrid question. That's not a nice one.
So why is it the second difference? It's
That's what
going up in -1, -3, and -7.
I don't.
Because you
No, it's just, that's the difference between them, and we're looking at that sequence there. So that's like an nth term. Yeah, yeah. Let me try and explain it again. Well done for getting around that. Okay, sorry, can I try and explain that again? Because I got myself confused there, but you lot have managed to make me understand the answer, so that's obviously well done to you. That was my sequence. Now we looked at that, and we looked at the first difference here, and we saw that was 1, 3, 5, and 7. So then we looked at the second difference, and they were all 2s. Now if they're all 2s, that tells me it's n squared. Okay? Now the issue I was having was I knew that from here, if I ignore that 0, I knew they were the square numbers, but it starts at 0. Okay, so that's what's making this hard work. If I write out what n squared is, it's 1, 4, 9, 16, 25, and so on. Okay, so the way that I get from here is that I take away 1, take away 3, take away 5, take away 7, and take away 9. Okay, now what I was making the mistake of doing before, I was saying, oh, there's a second difference of that. It's not, it's just literally, usually what happens here, if that was just like -1, -1, -1, -1, I chuck on -1 on the end here, but I haven't got that. So what I look at is what that sequence is going up in, or in our case, going down, and it's going down in 2s every time, isn't it? So if it's going down in 2s, it's -2n. Just like we had with the top question being going up in 8s, we said it was +8, I wrote +8n, or just 8n. The fact it's going down in 2s, that's why it's -2n. Okay, so from here, I would go and then check the term in front of the first term. If that's minus 2, minus 3, minus 5, if that's going down in 2's this way, it must be going up in 2's this way. So this must have been 1 here or positive 1, the term in front of the first term. Just again, just like I found in 9a, I went and found the term in front of the first term, I do the same here. So then I get a plus 1 here. Okay, there's a way I can check as well, which is pick a term in the sequence. So if I pick this one here, that is the 1, 2, 3, 4, 5, 6th term. If I sub 6 into this, then it should give me 25. So 6 squared, 36. Take away 2 times 6, 24, and then 24 plus 1 is 25. Okay? That was nasty though. You saw that got me confused.
So
They're good ones to look at.
I still don't get how it's plus 1.
Plus 1, because you always come and find the term in front of the first term on a regular linear sequence when it's going up or down the same numbers. So like I did on the very first one, I came and found minus 3, that term in front of the first one.
So if the difference is minus 2,
Yeah?
1 thing.
So the difference was minus 2, but that's going down, isn't it? I take away 2, take away 2, take away 2, take away 2. The other way, I'm adding 2, adding 2, adding 2. So you add 2 to minus 1. Okay?
Got it.
All good? Okay, and last one, on 9 that is. Here are the first 5 terms of a descending sequence of numbers. 126, 122, 118, 114, 110. So they said minus 4n because it's going down in 4s, and they found the term in front of the first term, which is 130. So very similar to literally what we just looked at. It says, without listing any further terms of the sequence, find the value of n that gives the first negative term of that answer. Okay, that's an interesting question. First negative, right, first of all, it's negative, so it's got to be either minus 1, minus 2, minus 3, minus 4, or minus 5, isn't it? Because it's going down in minus 4, isn't it? So it can't go further. So it could have been that I get to 3, and then you take away 4 and you get minus 1. It could have been I got to 2, then you take away 4 and you get minus 2, 1. And so it could only be actually minus 1, minus 2, minus 2, and minus 4. In terms of how we do that, it's just basically solving an equation is probably the way I'd look at it. If they see you're writing down any more terms, they're then going to automatically take off your marks.
You just write on the other page.
You could do if you want to on the back. They're not going to check there, are they? What I would probably do myself is I'd take away. Right, this is what I do actually. I haven't seen this paper. It's nice not actually seeing it because I can tell you exactly how I'm thinking. I take away 4 again in my head and get 106. Take away 4 again and get 102. Take away 4 again and get 98. And then I know if I take away 100, I know 4 goes into 100. So the first one's going to be minus 2, isn't it? Okay. So working out, I know the first term must equal minus 2. Agreed? Okay, so I did that just by taking a few more terms away in my head. I didn't write them down. I said 106, take away 4, 102, then 98, and then I said, well, 98 take away 100. I know 4 goes into 100, it goes into 125 times, then I can work this out. Okay, so I know this 130 minus 4n must equal minus 2. I want to work out what n is. I want to work out what number in the sequence. So it's just solving an equation now.
Oh, this is easy.
Okay, take away the 130, take it over, becomes, careful, minus 132, yeah, and then I'm going to take the minus 4 over and it's going to become divide by minus 4. And minus divided by a minus, it's plus, I can just cancel those out. 4 into 132, no idea. Is it? Very good. 4 into 13 goes in 3 times, remainder 1. 4 into 12, 3 times, so it's spot on and is equal to 33.
Because you can do it.
Ed,
I got 33, but my working out 2 lines.
how did you do it then? Have I overcomplicated it? Did I borrow your work? Okay, that's clever. Scan. Okay. Okay, a nice bit of quiet, please. Still waiting. Okay, and the way that Ed did it, he did 130 divided by 4, and then you've decided to then do 120 divided by 4, and then worked out that 10 divided by 4 was 2.5. Put them together, he's got 32.5. And then he said, so what have you done from there, Ed?
No, I was just saying the lowest value, the lowest whole number, which was above 50.
Yeah.
Yeah, that's what I did.
That's a clever way of doing it.
That's what I did.
I don't know if I can really explain all the steps that you've done. I think it's sort of one of those things, I sort of guess it looking at it, but I find it hard to actually put it into words exactly what you've done. So 130 divided by 4, it's telling you, yeah, so if you're to get 0, I think that's what that's doing, it's getting 0, and it's when it's 32 and a half terms, and that obviously wouldn't work, but obviously if you go up to the next term, it's then going to go into the negatives. That's a really clever way. Okay, so do you want me to try and explain that again? If we do 130 divided by the 4, because it's going down in 4s, I know that eventually if I divide that by 4, I find out that in 32 and a half terms, I'll get to 0. Now obviously you don't count in 32 and a half terms, you're counting either 32 or 33. But as soon as I go above the 32 and a half, I must be going past 0, so I must be going into the negatives. I like that, Ed, that's clever, very clever. Okay, thank you. Right, this is the one I wasn't looking forward to because it's got an awful lot of writing in it.
Can we do it on our own? And then
Yeah?